If the best and the worst paper never appear together, then 6 examination papers can be arranged in how many ways? A. 120, B. 480, C. 240, D. None of these. Therefore, the solution is, if the best and the worst paper appear together, the number of ways is 5 factorial into 2. Therefore, required number of ways are 6 factorial minus 5 factorial into 2 is equal to 480. Answer B. The number of 7-digit integers with sum of the digits equal to 10 and formed by using the digits 1, 2 and 3 only is option A 55, option B 66, option C 77, option D 88. Therefore, the solution is, there are two possible cases. Therefore, case 1, 5 1 1 2s and 1 3s. Number of numbers is equal to 7 factorial upon 5 factorial, that is equal to 42. For case 2, 4 1s 3 2s, that is number of numbers is equal to 7 factorial upon 4 factorial to 3 factorial, that is equal to 35. Therefore, total number of numbers is equal to 42 plus 35 is equal to 77. The number of ways in which 6 rings can be worn on the 4 fingers of one hand is equal to A 4 raised to 6, B 6C4, option C 6 raised to 4, option D none of these. Therefore, the solution is, starting with the first ring, number of ways it can be worn is 4. For the second ring, it can also be worn in any of the 4 fingers, so number of ways are 4. Similarly, for all the 6 rings, so number of ways are 4 into 4 into 4 into 4 into 4 into 4, that is equal to 4 raised to 6. Option A is the correct answer. How many numbers can be formed from the digits 1, 2, 3, 4 when the repetition is not allowed? Option A 4p4, option B 4p3, option C 4p1 plus 4p2 plus 4p3, option D 4p1 plus 4p2 plus 4p3 plus 4p4. So the solution is number of one digit number is equal to 4p1, number of two digit number is equal to 4p2, number of three digit number is equal to 4p3, number of four digit number is equal to 4p4. Hence the required number of ways is equal to 4p1 plus 4p2 plus 4p3 plus 4p4. Hence the option D is correct. How many numbers less than 1000 can be made from the digits 1, 2, 3, 4, 5, 6 when repetition is not allowed? Option A 156, option B 160, option C 150, option D none of the above. Therefore the solution is number of one digit number is equal to 6p1, number of two digit number is equal to 6p2, number of three digit number is equal to 6p3. Therefore the required number of numbers is equal to 6 plus 30 plus 120 is equal to 156. Therefore option A is correct. 4 buses runs between Bhopal and Gwalior. If a man goes from Gwalior to Bhopal by a bus and comes back to Gwalior by another bus, then the total possible ways are option A 12, option B 16, option C 4, option D 8. For the solution is, since the man go in 4 ways, man comes back in 3 ways, therefore the total number of ways are 4 into 3 is equal to 12 ways. Option A is correct. 9 balls are to be placed in 9 boxes and 5 of the balls cannot fit into 3 small boxes. The number of ways of arranging one ball in each of the boxes is option A 18720, option B 18270, option C 17280, option D 12780. Therefore the solution is required number of arrangements is equal to 6p5 into 4 factorial, that is equal to 720 into 24, is equal to 17280. Option C is correct. How many numbers lying between 999 and 10,000 can be formed with the help of the digits 0, 2, 3, 6, 7, 8 when the digits are not to be repeated? Option A 100, option B 200, option C 300, option D 400. Therefore the solution is the numbers between 999 and 10,000 are of 4 digit numbers. The 4 digit numbers formed by the digits 0, 2, 3, 6, 7, 8 are 6p4, that is equal to 360. But here those numbers are also involved which begin from 0. So we take those numbers as the 3 digit numbers. Taking initial digit 0, the number of ways to fill remaining 3 places from the 5 digits 2, 3, 6, 7, 8 are 5p3 is equal to 60. So the required number is equal to 360 minus 60, that is equal to 300. Therefore the option C is correct. If NP4 says 2, NP5 is equal to 1 raised to 2, then N is equal to option A 4, option B 5, option C 6, option D 7. Therefore, the solution is n factorial upon n minus 4 factorial into n minus 5 factorial upon n factorial, that is equal to half. Therefore n minus 4 is equal to 2 for n is equal to 6. Option C is correct. How many words can be formed from the letters of the word courtesy, whose first letter is C and the last letter is Y? Option A 6 factorial, option B 8 factorial, option C 2 bracket 6 factorial, option D 2 bracket 7 factorial. Therefore, the solution is, since C and Y are now fixed, remaining letters are 6 that can be arranged in 6 factorial ways. Therefore, option A is correct. In how many ways can 10 true or false question be replied? Option A 20, option B 100, option C 512, option D 1024. Therefore, the solution is, hence we know that every question may be answered in 2 ways. Therefore, required number of ways is equal to 2 raised to 10, that is equal to 1024. Option D is correct. How many even numbers of 3 different digits can be formed from the digits 1, 2, 3, 4, 5, 6, 7, 8, 9? Repetition is not allowed. Option A 224, option B 280, option C 324, option D none of these. Solution is, the number will be even if last digits is 2, 4, 6 or 8, that is last digit in 4 ways. And the remaining 2 digits can be filled in in 8p2 ways. Hence, the required number of numbers are 8p2 into 4, that is equal to 224. Option A is correct. The number of arrangements of the letters of the word banana in which two Ns do not appear adjacently is option A 40, option B 60, option C 80, option D 100. Therefore, the solution is, required number of arrangements is equal to total number of arrangements minus number of arrangements in which n's are together, that is equal to 6 factorial upon 2 factorial into 3 factorial minus 5 factorial upon 3 factorial, that is equal to 60 minus 20 is equal to 40. Option A is correct. Find the total number of 9-digit numbers which have all the digits different. Option A 9 into 9 factorial, option B 9 factorial, option C 10 factorial, option D none of these. Therefore, the solution is, there are 10 digits in all 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. The required 9-digit numbers is equal to total number of 9-digit numbers including those numbers which have 0 at the first place minus total number of those 9-digit numbers which have 0 at the first place, that is equal to 10p9 minus 9p8 is equal to 10 factorial upon 1 factorial minus 9 factorial upon 1 factorial, that is equal to 10 factorial minus 9 factorial is equal to 10 minus 1 9 factorial, that is equal to 9 into 9 factorial. Option A is correct. 4 dice 6 faced are rolled. The number of possible outcomes in which at least one die shows 2 is option A 1296, option B 625, option C 671, option D none of these. Therefore, the solution is the number of possible outcomes with 2 on at least one die is equal to the total number of outcomes minus the number of outcomes in which 2 does not appear on any die is equal to 6 raised to 4 minus 5 raised to 4, that is equal to 1296 minus 625 is equal to 671. For option C is correct. 4 note of rupees 100 and 5 note in which first of rupee 1, second of rupee 2, third of rupees 5, fourth of rupees 20 and fifth one of rupees 50 distributed among 3 children such that each child receive at least one note of rupees 100. The total number of ways of distribution: option A 3 into 5 raised to 3, option B 5 into 3 raised to 5, option C 3 raised to 6, option D none of these. Therefore, the solution is total number of ways to distribute 1 rupees 100 note and 5 other notes is equal to 3 raised to 6. For option C is correct. In how many ways can 5 prizes be distributed among 4 students when every student can take one or more prizes? Option A 1024, option B 625, option C 120, option D 600. Therefore, the solution is, since each prize can be distributed in 4 ways, therefore the required number of ways are 4 raised to 5, that is equal to 1024. So option A is correct. In a train, 5 seats are vacant, then how many ways can 3 passengers sit? Option A 20, option B 30, option C 10, option D 60. Therefore, the solution is, for first passenger there are 5 ways. Second passenger there will be 4 ways, and for third passenger there will be 3 ways. So the total number of ways is equal to 5 into 4 into 3, that is equal to 20 into 3, that is equal to 60. So the correct answer is D. Assuming that no two consecutive digits are same, the number of n digits number is option A n factorial, option B 9 factorial, option C 9 raised to n, option D n raised to 9. Therefore, the solution is digit at the extreme left can be chosen by 9 ways, as 0 cannot be the first digit. Now for the second digit, it can be done in 9 ways, as consecutive digits are not same, and this is same for next digits. Hence the number of ways are 9 into 9 into 9, that is n times, that is equal to 9 raised to n. Option C is correct. The sum of the digits in the unit place of all numbers formed with the help of 3, 4, 5, 6 taken all at a time is option A 18, option B 432, option C 108, option D 144. Therefore, the solution is, if we fix 3 of the unit place, other 3 digits can be arranged in 3 factorial ways. Similarly for 4, 5, 6. Therefore, the required sum is equal to 3 factorial 3 plus 4 plus 5 plus 6 is equal to 6 into 18, that is equal to 108. Option C is correct. 6 identical coins are arranged in a row. The number of ways in which the number of tails is equal to the number of heads is option A 20, option B 9, option C 120, option D 40. Therefore, the solution is number of heads is equal to 3, number of tails is equal to 3, and coins are identical. Therefore, required number of ways is equal to 6 factorial upon 3 factorial into 3 factorial, that is equal to 720 upon 6 into 6 is equal to 20. Option A is correct. The figures 4, 5, 6, 7, 8 are written in every possible order. The number of numbers greater than 56,000 is option A 72, option B 96, option C 90, option D 98. Therefore, the solution is number will be less than 56,000 only if either 4 occurs on the first place or 4 occurs on the first two places. Therefore, required number of ways is equal to 5 factorial minus 4 factorial minus 3 factorial, that is equal to 120 minus 24 minus 6 is equal to 90. Therefore, option C is correct. Number of ways in which 7 distinct objects can be distributed among 4 children. Option A P bracket 7 comma 4, option B 7 factorial, option C 4 factorial, option D none of these. Therefore, the solution is required number of ways is equal to 7p4, that is equal to p7 comma 4. For option A is correct. The sum of all 4-digit numbers that can be formed by using the digits 2, 4, 6, 8. Repetition of the digits not allowed. Option A 13332, option B 533280, option C 53328, option D none of these. For the solution is sum of the digits in unit place is 6, 2 plus 4 plus 6 plus 8, that is equal to 120. In tens place is equal to 120 tens. In hundreds place is equal to 120 hundreds. Therefore, sum of all the 24 numbers is 121 plus 10 square plus 10 cube, that is equal to 120 into 111, that is equal to 13320. Option A is correct. There are 5 roads leading to a town from a village. The number of different ways in which a villager can go to the town and return back is option A 25, option B 20, option C 10, option D 5. Therefore, the solution is the man can go in 5 ways and he can return in 5 ways. Hence, the total number of ways are 5 into 5, that is equal to 25. Option A is correct. Let the 11 letters A, B to K denote an arbitrary permutation of the integers 1, 2 to 11, then A minus 1, B minus 2, C minus 3 to K minus 11. Option A necessarily 0, option B always odd, option C always even, option D none of these. Therefore, the solution is given set of numbers is 1, 2 to 11, in which 5 are even, 6 are odd, which demands that in the given product it is not possible to arrange to subtract only even numbers from odd numbers. There must be at least one factor involving subtraction of an odd number from another odd number. So at least one of the factor is even. Hence product is always even. For option C is correct. The number of ways in which first, second, and third prizes can be given to 5 competitors is option A 10, option B 60, option C 15, option D 125. Therefore, the solution is first prize can be given in 5 ways, second prize can be given in 4 ways, third prize in 3 ways. Since a competitor cannot be get 2 prizes, and hence the number of ways is equal to 5 into 4 into 3, that is equal to 60 ways. Therefore option B is correct. The number of 3-digit odd numbers that can be formed by using the digits 1, 2, 3, 4, 5, 6 when the repetition is allowed. Option A 60, option B 108, option C 36, option D 30. Therefore the solution is, since the number to be formed is odd, extreme left place can be filled in 6 ways. Equal to 6 ways. Middle place can be filled in 6 ways. Extreme right place can be filled in 3 ways. Therefore, required number of numbers is equal to 6 into 6 into 3, that is equal to 108. For option B is correct. How many numbers of 5 digits can be formed from the numbers 2, 0, 4, 3, 8 when repetition of the digits is not allowed? Option A 96, option B 120, option C 144, option D 14. Therefore the solution is numbers are 2, 0, 4, 3, 8. Numbers can be formed is equal to total minus those beginning with 0, that is equal to 5 factorial minus 4 factorial is equal to 120 minus 24, that is equal to 96. Option A is correct. If the letters of the word Sachin arranged in all possible ways and these words are written out as in dictionary, then the word Sachin appears at serial number option A 603, option B 602, option C 601, option D 600. Therefore the solution is words starting with Sachin are each at equals to 5 factorial. Therefore total words is equal to 5 into 5 factorial, that is equal to 600. The first word starting with S is Sachin. Therefore, Sachin appears in dictionary at serial number 601. Therefore, option C is correct.